NASA's Jet Propulsion Laboratory presents the Von Karman Lecture, a series of talks by scientists and engineers who are exploring our planet, our solar system, and all that lies beyond.
It's 1965. A gallon of gas cost 31 cents. Goldfinger was the year's top movie. The Beatles album A Hard Day's Night won a Grammy. And Mariner 4 became the world's first successful mission to Mars. Here are 5 things you probably didn't know about it. Mariner 4 was the first spacecraft to navigate using the stars, like ancient mariners that sailed the seas. Mariner 4 went farther than any other human-made object at the time, and used the bright star Canopus as a reference. Once its star sensor found Canopus, gas jets on the spacecraft kept the vehicle locked in the correct orientation for the trip to the red planet. Mariner 4 reached Mars on July 14, 1965, and took 22 pictures as it flew by. They were the first pictures ever taken of another planet from deep space. The pictures showed moon-like craters, shattering the idea of finding life on the surface, but opening the age of scientific Mars exploration. Mariner 4 carried an analog television camera, the best technology at the time. The pictures were sent back digitally as ones and zeros. While waiting for early computers to process the data, engineers anxious to see a picture created their own by hand-coloring printouts, paint-by-number style. It was the first digital image of Mars from space. Radio dishes on Earth picked up Mariner 4's data at just 8.5 bits per second, an amazing feat at the time, given the large distances involved. It took a week to send the 22 images back to Earth. Today, the Curiosity rover sends data almost 250,000 times faster than Mariner 4. Mariner 4 also discovered that Mars has a very thin atmosphere. This discovery was made by the spacecraft sending radio signals through the Martian atmosphere as it passed behind the planet. This first ever visit to Mars was a boost for the United States in the midst of the Cold War with the Soviet Union. President Lyndon Johnson passed out medals to NASA and the Jet Propulsion Laboratory for the success of Mariner 4. A lot has changed since Mariner 4. Back then, a typical engineer wore a white shirt, pencil tie, and often a pocket protector. Today, not so much. A half-century may have passed, but the nation's pride in Mars exploration remains. Mariner 4 set the stage for future missions that flew to Mercury, Venus, Mars, and even the outer planets.
Well, I hope that whets your appetite for exploring Mars tonight, because that's where you're going. How many people in this room have worn very narrow black ties before? Oh, good, that's good. They're your club members. Well, welcome to the Von Karman Lecture Series. My name is Stephen Klazicki. I'm with the Jet Propulsion Laboratory in the Communications and Education Organization, and we're delighted you're here with us. This is a very special room. This is a place where all these discoveries were presented to the world for the very first time, and you are here right in that space. But let me tell you a little bit about the person you're here to listen to. Our presenter tonight is a storyteller. He's an historian, and he's a space exploration evangelist. He, unlike most of the people around here, is an English major, started out that way, has spent a stint in the Peace Corps, and was a TV producer in his home state of Mississippi. I first heard about him in the very late 70s because there was this stuff about a hotshot promo producer at PBS making these great promos for Carl Sagan's Cosmos series. And that was the first time I heard the name of our presenter tonight. He went on from there to write and produce a remarkable series of television projects over the next couple of decades. One called Spaceflight that to this day is maybe the most comprehensive story of the American space program ever made. He made a series called The Astronomers on astronomy in the early 1990s here. in the U.S. Another complex story about secret intelligence in this country, and then an amazingly interesting story called The Great War and the Shaping of the 20th Century that was this rendering of how the end of the 20th century was very much like the beginning of the 20th century. Somewhere in there, he was one of the finalists for the Journalists in Space program, but then the Challenger incident happened and that program was canceled. He's authored 2 books on some of the subjects I was just talking about. His programs have won almost every major award in the television industry. He was recruited by the great Edward Stone to come to JPL in late '99, and some of you may remember that was the year that some things didn't go so well here at JPL, and there was a bath of fire in terms of dealing with the public in that complex time of the failure of those 2 missions to succeed. But he pressed ahead, and much, if not all, of the extraordinary work that JPL has done in public engagement in the 20th century has been under the leadership of your presenter tonight. In 2012, he won NASA's highest honor of a Distinguished Service Medal for the work that has been done here. And since over the last 7 or 8 years, he has produced a series of 6 feature documentaries about this laboratory and its history that will be a perpetual legacy and gift about the extraordinary things that happen at this laboratory. So here to salute the very historic story of Mariner 4 and the people who put it together and made it happen, please welcome to the stage JPL's Director of Communications and Education and my pal, Blaine Baggett.
Thank you. Good evening. I think I better quit while I'm ahead, don't you? Thank you for that. I really do appreciate those kind remarks, Stephen. Okay, so what a week, huh? Hasn't this been an amazing week? Okay, just let's go to Pluto, just for a second. Ladies and gentlemen, Pluto. Congratulations to NASA. Congratulations to the Applied Physics Lab in Baltimore. They have just done a fantastic job of delivering this last piece of the outer part of the solar system in the planetary system. Just so remarkable that, I've lived to see this. It's just fantastic. And I don't know if you've followed it very much, but do you realize what this is? Any idea? Those are mountains. Those are mountains. They are 11,000 feet tall and they're solid ice. Ice mountains. Incredible place. And the thing, I'm a literature major, so check every fact that I say, all right? Go on the internet. But what is amazing about this is that there's very few craters that they're finding, which means this is a very young place. And this kind of process has happened recently. And you can think of Pluto is alive. It is alive geologically. The solar system, the one thing we're finding out more than I think that is more important than anything, beginning with Voyager telling us this, particularly with Neptune and Uranus and their moons, is that the solar system is not just a place where things cold and solid are running around, or gas planets are running around. It is evolving even as we speak. Now, I want to point out one more thing. When I looked at this image, I was struck. Can you see this? Can you see that line across there? I looked at that and I said, well, I also looked at this line up at the top there on the right-hand side, and what is that also? But I was particularly struck with this line when I saw it. And remember, I'm just a literature major, not a scientist. But then I looked at Mars, and I saw this line. I know this line. This is called Valles Marineris. It is a Grand Canyon that puts our Grand Canyon to shame. It is 3 times deeper than our Grand Canyon, and it stretches on Mars the equivalent of from Los Angeles to New York. Okay? So I thought, that looks like a Grand Canyon to me. And I said that just to myself this morning, and lo and behold, later on today I looked on the internet and they said they think it's a canyon, but I think I discovered it first. Okay, all right, but let's talk about Mars. What is it about this place? Why do we care so much about Mars? I want to give you my thoughts on it. Again, it's just a mere storyteller, not as a scientist, not as an engineer, because I'm none of those things. But I am as fascinated with Mars because people are fascinated with Mars as I am fascinated with just Mars for the fact that it's an incredible place. It strikes something incredibly deep in the human imagination. Now, this is Mars 1. This is a private enterprise of folks that want to go to Mars with human beings in the next 11 years and start a colony. They've had over 1,000 volunteers. They're cutting, I went on the internet and looked today, they are culling down the number of the final recruits that they're willing to consider. However, they're only giving away a one-way ticket. I don't give them a lot of hope, but boy, do I appreciate the fact that they are that passionate about Mars and want to go there. I think we want to go to Mars for a lot of reasons. We want to go there. We'll go back to Mars just for a second. We have a commonality with Mars that we see. First of all, it's a rocky planet like ours. You go further out, it gets to be gassy planets. It has polar caps, as you can see. Has an atmosphere, we've already heard about that. Has a Grand Canyon. Has a volcano the size of the whole state of Arizona. Right? Its day is 24 hours and maybe 30 more minutes longer, but it's almost exactly the same rotational. It has its axis kind of wobbles to the point where it has seasons like on Earth. There are a lot of things that we think of that Mars makes us feel kind of like it's a place where we could go, like our place. That's science. That's the science fact of Mars. Then there's the science fiction of Mars. We have made Mars into an incredible, iconic character in human culture. All through the years. People would look up at the night sky, the ancients would look up at the night sky and see this wanderer, this red, distinctive dot in the sky, and wondered about it more than other places. And in more recent years, we have H.G. Wells, Orson Welles, right, Ray Bradbury, any number of folks who have taken Mars and made it into a place where, more than anything else, they have delivered one message, and that is that Mars is a place with life. Now, I don't really think this is going to happen anytime soon, not in 11 years, but I really am excited about what they wish to do. But NASA wants to go to Mars also. NASA is building its entire human program around a new spacecraft named Orion. You can kind of think of it as Apollo on steroids is one way it's talked about. And they're wanting to take, here's kind of their larger plan. And it's more complex, got more assets going for it. It's going to use, of course, all the assets that we have around Mars. It wants to, the idea is to take the spacecraft and have the astronauts really learn their ropes by going out and retrieving an asteroid and bringing samples of it back to Earth. And then later on, in the 30s or so, really get serious about going out to the red planet. And my guess is what will happen, I don't know, I'm just speculating from history, but when we first went to the moon, we didn't land on the moon. We sent astronauts to the moon, had them go around and come back. And we may do that. We might land on some of the actual moons of Mars first. But it's going to be a very thoughtful plan that uses all of the assets that we have to get there. And the good news is NASA plans on having a round-trip ticket for the astronauts. But we're already on Mars. We don't have footprints on Mars, but we have wheel tracks, right? We first landed with the Vikings. NASA's Langley Center actually was in charge of it. JPL got a lot more credit than it probably deserved, but the Langley NASA Center in Virginia was in charge of the Viking mission. We provided the orbiters that landed landers on Mars in 1976. And we've gone back since with orbiters. We landed Pathfinder. We've gone Phoenix. We've had the opportunity in Spirit. And there's this one mission about 3 years ago. It landed on Mars. I can't really remember the name of it. Does anybody remember what it might be? What was it called?
You'll get the opportunity.
I'll get the opportunity? Okay. No, almost 3 years, maybe give about 3 weeks from now, will be the 3rd anniversary of Curiosity landing on Mars. I don't know where you were, but I was in mission control, and it's one of the most extraordinary experiences I've ever had. The only thing I can compare it to is when my boys were born. So I don't know where you were, but I want to take you back and see where some folks were when we landed Curiosity.
Things are looking good. Coming up on entry. Vehicle reports entry interface. At this time, it will begin pressurizing the propulsion system to increase the thrust of the system. We'll use that for all the maneuvering in the atmosphere we're about to do. We are standing by for guided start of guided entry. We are beginning to feel the atmosphere as we go in here. The vehicle has just reported via tones that it has started guided entry. At this time, the vehicle is beginning to steer its way to the target. We have seen peak deceleration. That is starting its first bank reversal. It is reporting that we are seeing G's on the order of 11 to 12 Earth G's. Bank reversal 2 is starting. We are now getting telemetry from Odyssey. We should have parachute deploy around Mach 1.7. The parachute is deployed. We are decelerating. Heat shield has separated. We've found the ground. We're down to 90 meters per second at an altitude of 6.5 kilometers and descending. Standing by for backshell separation. We are in powered flight. We're at an altitude of 1 kilometer descending. Standing by for sky crane. Sky crane has started.
Signal to us, you remain strong.
Touchdown confirmed. We're safe on Mars. Time to see where our curiosity will take us.
Thumbnail.
I still can't watch that without getting emotional. It's just incredible. What is it about Mars? Is it the technology? Is it because we touched it? What is it about this place? And somebody who also had an incredible passion about Mars, we're going to go back over 100 years now, was this fellow. He was a serious astronomer, Percival Lowell. But he had just as serious an imagination as he did a dedication for the quest to find things. And he was convinced, this is the end of the 19th, early part of the 20th century, he was convinced that he was seeing things on Mars through his telescope. And another, I think, very important attribute of the human imagination and just our human instincts is pattern recognition. We have evolved as a species and have survived in part because we're able to recognize patterns. We can see when there's something over there that might hurt us or something over there that might help us. And he looked up at Mars through the telescope and he saw patterns. And the patterns that he saw were straight lines that he said, well, that can't be part of the natural world. Something has caused those lines to be. And picking up on astronomers from further back in time, he thought, okay, well, I think there's civilizations. I think that there are cities with smokestacks. I think there are navies floating on oceans there. No one in the science community took him seriously, but he kept alive the ideal of Mars as a place that is alive. But interesting to me, and to relate it to this evening a little more, or this week I should say, is he, in the last few years of his life, turned away from Mars and looked out further into the solar system, particularly to Neptune and Uranus, and thought that there was something not quite right about their orbits. So he was convinced there was something called Planet X out there. So he spent a lot of his last years looking for Planet X. They didn't really find that. It was a bit of a wild goose chase, but it did ultimately, they found there was something out there, and it's called Pluto. So there's a connection to Mars and Pluto in that way also. There's even Pluto, Percival Lowell, PL. You know, there's a connection there. Okay. Pattern recognition gone astray. All right? This I call the image that launched 1,000 conspiracies. It's 1976. The Viking orbiters, built here at JPL, are orbiting and sending back images. And this was one of them. It's an area called Cydonia. And if we look at it closer, you'll see it looks like a face to me. And it generated a lot of interest in Mars again as a place where we, with our human imagination, with our need to connect, we are built to connect, to build community with others. And we've taken that notion and we've extended it out now into the solar system. So we went back to Mars, of course, with orbiters later on, and more recently, in fact, there's a half-scale model right back here called the Mars Reconnaissance Orbiter here in the corner. incredible camera on this spacecraft. Still orbiting Mars, sending back great stuff now. Gave us this image. That's the face on Mars. That's really it. So we all recognize patterns in nature. We can look up at clouds and see things, right? It's part of our human nature, but we have to be very careful about what we think we may be seeing. There is a face on Mars, though. That's real. I keep looking for somebody putting out a sign saying, have a nice day. Okay. This is a real face on Mars. Abe is now on Mars. Now, you might ask, why would that be? This is a penny. It was actually minted in 1909. It was the year that I guess the penny first came out with Abraham Lincoln on it. And this is a camera called Molly taking a picture of it, his own curiosity. And it's an incredibly, high-powered camera that can get up close. And notice all the dust on it, right? To the small specks. Very powerful. Now, why would they have done this? Well, they have a color calibration system there to make sure they're getting the colors right. And so they decided to put Abe there too. So as far as I know, that's the only authentic picture of a face on Mars to this day. I have it on reliable sources. Okay. Pattern recognition again. This is the Allen Hills rock meteorite that was found in Antarctica, I think in 1984, somewhere around in there. Now you might ask, how did a piece of Mars get here? The idea is that something hit Mars, a lot of rocks blew off of Mars, orbited around the solar system, got sucked into the gravitational force of the Earth, survived re-entry, and that's a piece of Mars. All right, and these clever scientists have ways of looking at the chemical composition and saying, yes, this matches Mars, and I take their word for it. I'm just a literature major. So they opened this up. They sliced into it. And they looked at this, and the idea was they felt they were seeing evidence of fossilized life, microorganisms, bacteria, which they said was the possibility that it might be that. They didn't declare that it was. The NASA scientists were involved in this. And it caused a major discussion of whether it was life or not, which still goes on to this day. But it also ramped up the Mars space program for NASA, and NASA got very, very serious about going to Mars after that. And of course, we've been very, very involved in that since. Okay, enough of the context for this. Now let's go back. We're here tonight in a room, as Stephen said before, where 50 years ago in 2 days, 50 years and 2 days, in this very room, it was packed just like this. And the people in this room were waiting to try to get some glimpse of Mars, because in 1965, that was the best sort of image. Those are the best images we had of Mars through a telescope. It's kind of hard to believe now, isn't it? Isn't it, to put yourself back that far and realize that's all we could see? The scientists didn't think there were little green men on Mars, but they were very wide open to the idea there might be vegetation on the surface, sagebrush tumbling by or something. Some notion of they knew it was cold, but would there be water there somewhere on the surface? So that's all we had. And we didn't really know very much about how to build spacecraft. My good friend, you're going to get to meet him in this film, John Cassani, who was involved in the mission, one of the grand old engineers at JPL, has told me back then we didn't know what we were doing, and there was no one to tell us what to do, because no one had done any of these things before. So they had to learn by trial and error. So there was before there was a Mariner 4, there was a Mariner 3. The Mariner 3 went up. The cover on the spacecraft didn't come off. It went into the Atlantic. Imagine building, your first mission that you want to go to Mars, and it goes into the Atlantic. Well, back in those days, just like we did Spirit and Opportunity, where we had two, or the Voyagers, there was Voyager 1 and Voyager 2, there was a reason why they did 2 of everything, because they were so worried that it might not work. They thought we'll increase the odds by building 2 of things. So they still had Mariner 4. So we're going to hear that story now. And I am so grateful to what the laboratory did, a very wise decision in 1965, is they hired one of the greatest all-time cinema verite documentarians to come and document what happened here. His name was Bob Drew. He's somebody I studied, and looked up to for many, many years. So all the black and white footage that you're going to see tonight, I think almost all of it came from his documentary. So I took that footage. I took other things that we have here at the laboratory that just been in the vault. No one had seen it for years. And I told the story of our first journeys to Mars. But we're only going to watch the first 30 minutes of a 90-minute film tonight because it focuses on Mariner 4. So sit back, get into this time machine that we're in right now, and let's go back to 1965. Thank you.
Hello, I'm John Fitch. Man, since the beginning of time, has wondered about the stars and the planets. Our neighbor planet Mars has intrigued the imagination of artists and writers. Some people think there is life on Mars.
I see a vast network of channels crisscrossing the planet. Obviously the work of intelligent Martians. The simplicity and symmetry cannot...
It will be possible with larger telescopes to see cities on Mars, to detect navies in its harbors.
The inhabitants of Mars are vast, cool, and unsympathetic intellects, looking across space at the planet Earth with envious eyes. Are they planning an invasion?
We've been looking at Mars the way artists and writers imagine it. A planet of jungles and deserts, inhabited by monsters, and of course, beautiful women. Well, I'm happy to say that they are wrong. Mars is far more mysterious than that, and far more surprising.
Of all the planets in our solar system, Mars has always held the most fascination. There is no longer hope of little green men. But the question of whether microbial Martian life might have once, or still might exist, remains. This is the story of the first pioneering missions to reach Mars, and how each encounter resulted in surprise, dismay, or delight for those who first took us there.
Each time we got more data, each time we got closer, that image was completely obsolete. That's still going on. That's the amazing thing.
The changing face of Mars. Beginnings of the space age. Next. In the Cold War between the United States and the Soviet Union, the space race was a great drama played out before the entire world. At the beginning, the Soviets, with their powerful rockets, were far ahead. But that began to change when NASA's Jet Propulsion Laboratory scored America's first in space by sending a robotic spacecraft sailing by Venus in 1962.
And in those days, intense Cold War rivalry, you were dealing with things that had military implications. And so countries of the world were trying to say, well, who's going to win this? Who's going to be the dominant military power? And so we had a lot at stake. It wasn't just trying to get a satellite.
The name of the game was Beat the Russians. The space race was very real and very tangible here at JPL. We knew that our job was to get there first and get there best.
And now JPL was aiming for Mars, as were the Soviets. In June of 1963, Mariner project manager Jack James announced results of the latest Russian attempt to reach the Red Planet.
Today, the USSR spacecraft Mars 1 made its encounter with Mars, dead as a doornail. The Soviets have made at least 7 launches to Venus and Mars, none of which have succeeded. You are better than they are. You are one of the individuals who can make Mariner the first spacecraft to make measurements of the planet Mars. This depends on each of you as an individual. Your initiative, your craftsmanship, your ingenuity, your precision. It is up to each of us to make every day count.
What Jack James' memo did not say was how hard it would be to reach Mars. Although JPL's Mariner 2 had been first to reach another planet, the spacecraft had barely survived the 3.5-month journey to Venus. Traveling to Mars would take almost twice as long. And nearer to home, 5 attempts in a row by JPL spacecraft just to crash land on the moon had failed.
The first thing we'll have to do is organize a team the best we can get. We're going to have to come up with a spacecraft design that will perform for at least 250 days outside the orbit of Earth and out to the orbit of Mars.
The first challenge was just getting there. What you did once you got there was kind of frosting on the cake. It was like climbing Mount Everest and planting a flag. It's not planting the flag that's important. It was just getting there.
The United States took great pride in having been first to Venus. It was an accomplishment widely acclaimed, from the Rose Parade to the White House. But the achievement did not automatically give JPL a green light to proceed on to Mars. The lab had to compete against a proposal by NASA's Goddard Space Flight Center in Maryland. Goddard wanted to land on the Martian surface. JPL's more cautious proposal was to replicate their success at Venus, launching 2 identical spacecraft to fly by Mars, with hopes that at least one would make it there. Ultimately, the choice was made for NASA when it became clear that the rocket the Goddard proposal required would not be available. Still, JPL's more conservative approach did not mean easy. Just reaching Mars was an enormous challenge. And JPL's mission to Venus had been with just a souped-up version of a spacecraft built only to reach the moon. Going to Mars required a real deep space flying machine.
Mariner 4 was really the first spacecraft that were specifically designed for planetary exploration. Mariner 4 had all of the things that became characteristic of JPL missions after that. An integrated packaging and structural design, an octagonal bus, extensive use of louvers for temperature control, 3-axis stabilized, loaded with instruments that could articulate and point.
Traveling away from the sun meant encountering a colder, more hostile environment with less ability to draw power. The solar panels had to be more than twice the size of those flown to Venus. For the first time, the Earth could not be used for establishing the spacecraft's orientation, known as attitude control. Instead, these spacecraft would have to fly by sighting a star.
The spacecraft will roll, permitting the star sensor to search for Canopus. Once sighted, the gas jets will keep it locked on. It may be a very difficult operation, which will have to be backed up by ground command.
Because distances were far greater, communications links arrayed around the world had to be strengthened. What came to be known as the Deep Space Network.
Stations are so located that a spacecraft in deep space will be in direct line-of-sight contact with at least one of the stations continuously.
Above all, there was a very basic engineering concern. How long could a spacecraft withstand the harsh environment of space?
For one thing, instead of a 3-day mission, we were talking about a mission that was going to be 8 or 9 months. We went through the reliability analysis, and the number came out to be 30% probability of success. We tended not to believe the numbers, you know. We sort of convinced ourselves that God did not really ordain that resistors should fail at, 0.0, whatever it was, percent per 1,000 hours, and we just plowed on.
The twin Mariners 3 and 4, which some dubbed flying windmills, were remarkable feats of engineering. But flying to Mars was only half the challenge. Just reaching Mars would be an accomplishment in itself. But the larger goal was learning what was there. For scientists, capturing even a glimpse of Mars as a spacecraft flew past might answer whether life existed there. It was a question very much on the mind of Caltech geologist Bruce Murray.
You couldn't go to Mars without a camera. So a major development was finding some technology that could be used for a camera. NASA chose a well-known physics professor at Caltech by the name of Robert Leighton, a wonderful man, to set up the team and together design this first space camera system. In fact, it was the first digital camera of any kind.
After many meetings and a lot of give and take, we finally agreed that we should try to get a series of black and white photographs that should begin at the limb and continue across the planet to the shadowed area. The photographs should show detail at least 10 times better than any taken from Earth. Considering the altitude, angle of approach, possible resolution, and rate of sending back data to Earth, we designed the system to take 22 photographs.
Liftoff.
On November 5th, 1964, Mariner 3, with the world's first digital camera aboard, lifted off from Cape Canaveral, Florida.
The launch is always exciting. It was even more exciting in those days because about half of them were failing.
And that was Mariner 3's fate. Within an hour of launch, telemetry showed that the mission was in serious trouble. For some unknown reason, the spacecraft's solar panels were not drawing power.
It had enough energy to escape the Earth, but not anywhere near enough to get to Mars. So it only lasted as long as the batteries could last. It lasted a few hours. It was kind of devastating news, but to be honest, we were getting kind of used to that in those days.
The launch of Mariner 4 was now delayed while engineers worked against the alignment of the planets to understand what had gone wrong.
There were 3 weeks until Mariner 4 had to be launched because of this geometry between the Earth and Mars meant that you had to catch this window in time. So in that 3 weeks, JPL and the contractor figured out what had caused that failure.
The problem was tracked down to the nose fairing. Its purpose was to protect the spacecraft during launch. The contractor, attempting to reduce weight, had built it out of a light material that collapsed during ascent. Working around the clock before the launch window closed, engineers modified the fairing.
Clear to launch. We're counting. Engine start.
Remarkably, just 2 weeks and 3 days after the failure of Mariner 3, its twin was on its way to Mars.
Roger. 1 3 seconds. We're on our way. Roger.
Ahead was 7.5 months and 325 million unforgiving miles of travel through deep space. During the cruise, Jack James turned over the operation of the mission to Dan Schneiderman. He had been the spacecraft system manager for the mission to Venus. Schneiderman grew up on a chicken farm in Bakersfield, California. In World War II, he had worked in radar in the Aleutian Islands. Following the war, he used the GI Bill to get a degree in engineering. Then he got a job designing electric guitars. Unimpressed with the music most of them made, he quit and found his way to JPL.
He was a real character. And later in years, you know, I used to say, I would say in a group of people, I owe Dan everything I ever learned, I owe to Dan, or something like that. And he would get mortified. He would say, oh, Sonny, please don't say that. You know. He would wax philosophical. He liked to draw analogies, you know. I can remember him talking about resolution, what you can see with a camera.
It's interesting to look at things and look at them as you get closer. For example, if you go far away from, let's say, if you were an angel or something like that there, and you floated high above Southern California, you look down, you might see a greenery. See? And then you lower your altitude a little bit, and this greenery becomes patchy greenery. In other words, what looked to be homogeneous all of a sudden becomes random. Okay? You come lower, and all of a sudden what you're seeing is a single forest. So what was random becomes homogeneous again.
He was a worrywart, didn't sleep well. And he would say that the project is like a log floating down the river. All the people working on the project are ants crawling around this log, and the project manager is an ant at the front of the log, telling all the other ants to pull right, you know, to avoid those rapids up ahead, or to pull left. And of course, whatever the ants do doesn't make a damn bit of difference. The log is going to go where the river takes it. I think it was expressing a sense of helplessness, you know, that there's not much that anybody can do to influence the outcome.
Mariner 4's journey to Mars was relatively uneventful. The spacecraft at times had difficulty locating the star Canopus. That caused nervous moments when contact was sometimes lost. But only one trajectory maneuver was needed to keep the spacecraft on course, more or less.
In the beginning, when I first started, I was the trajectory engineer, so it was my job to design the flight path that would take the spacecraft from here to Mars.
The Mariner 4 trajectory, as it leaves the Earth and goes to Mars, will be approximately an elliptical orbit about the Sun.
We had not been to Mars with a spacecraft before, and as we were approaching the planet the last couple of hours, we realized that our estimates of the orbit were beginning to change significantly. In fact, we ended up missing by about 5,000 or 6,000 miles from where we'd aimed, which by today's standards is abysmal, but by those standards was actually not bad. You know, the last hour to half hour before occultation was a wild scramble of trying to run orbits, trying to get the last data, trying to get on the phone and call Goldstone and tell him what time to turn on the tape recorders. It was a wild scramble.
This is Mariner Control Center at JPL. Mariner 4 is currently being tracked by Station 51, Johannesburg. The spacecraft is 134.217 million miles from Earth and 50,142 miles from Mars.
As the spacecraft neared Mars, everyone knew this would be an historic moment. And a white-knuckled one. A flyby of Mars meant a single pass and no second chances. Schneiderman and his first lieutenant, Bill Collier, were working a long list of what-ifs. A major concern was the star tracker. If Mariner 4 lost sight of Canopus, the spacecraft might end up facing away from Mars during the flyby. And that would mean having successfully flown for 8 months through deep space, only to fail at the critical hour.
This discussion of Canopus, losing Canopus lock is meant to make a nervous man.
Oh boy, that just really scares you to death.
It does?
It really does. It just scares you to death. Because
if that hits us, we are really in trouble.
Boy, we're going to have a frantic day, no matter what time that might occur.
You're not the director.
While Schneiderman and Collier fretted, the science imaging team joked about what they might soon be seeing.
What are we going to do when we see HELP stamped out in the snow?
What John Cassani says we're going to see is a bunch of quack. These guys, these guys are going to be firing at us as we go by.
Meanwhile, the engineers considered more what-ifs. One was the spacecraft's primitive computer. It would be in control during the flyby. But if something went wrong, the computer had no backup plan. Should engineers leave well enough alone, or send up a new set of commands? That carried its own risk. New instructions might only confuse the spacecraft.
These are the questions, this is the soul searching you go through to, boy, don't worry. Our first reaction was, man, let that spacecraft perform for itself. Let's not horse around with it. But as soon as you start really asking these questions of yourself, then you begin to think, we can't take a chance. We've got to put ourselves in a position where we've done everything we can humanly do to ensure, or at least to enhance, the chances of success.
The main fear was that the tape recorder might not turn off. If that happened, the images would be recorded over following the flyby with the blackness of space.
If the tape recorder fails to turn off, we cannot tell that. And that's the rationale behind the transmission of DC-26, is to protect the pictures.
On July 14, 1965, another command called DC-25 was transmitted. With it, Mariner 4 began taking the first ever close-up pictures of Mars.
The DC-25 command should initiate a platform scanning action. If the command is not received, the spacecraft will initiate the scanning itself in about 1 hour. We expect that 21 pictures will be recorded. After other telemetry data are returned to Earth, the spacecraft will automatically initiate playback of the TV pictures.
The first picture will cover an area of approximately 176 miles square on the sunlit limb of the planet.
I wish I were as sure as he is.
About 12 minutes from now, we should be able to determine that the TV camera shutter is operating and that the recorder is running, although we will not be able to determine definitely whether pictures are actually being recorded on the tape until they are played back.
It's time for 26 to go.
26 was DC-26, the command for the recorder to stop taking pictures.
There it is.
The system had worked. The picture was recorded on board the spacecraft. That was a big deal.
Gee, it's not safe to say that's the only thing, because we're really subject to
just say everything is okay.
almost anything could occur.
Okay, good. I'm going to go get some lunch here. I hope in about another 15 or 20 minutes.
I just hope nothing unusual. I hope it keeps right on being just as easy as it's been so far.
That's what I want to do.
Later, Mariner 4 transmitted back a conflicting message. The tape recorder might not have worked as expected.
There were some extra events that came back via telemetry. And if you read those events in a certain way, it said the tape recorder had stopped recording. And that caused great panic among the management here.
Yeah, what about the tape recorder?
Well, the tape recorder, the answers that I got late here is that we got a normal first end of tape and a normal second end of tape, and it appeared as though that the second end of tape switched the data encoder to mode 2, just as it is supposed to. But the answer here, the last I heard there, was that there was some funny business in the first 10 picture recording.
That TV system, which should have turned the tape recorder on and off, may have failed to turn it off, and the tape runs through faster. And that was exactly the reason we sent this command 26, was to save as many pictures as we could on the tape. So we don't know for sure it's happening.
The actual time of transmission of DC-26.
Mariner 4 carried other science instruments. And those measurements were programmed to be transmitted back first. Only later would the pictures come, if there were any.
The data came back extremely slowly from deep space, went into the Goldstone tracking antenna out in the middle of the Mojave Desert, and came to JPL by teletype. It's that slow. Click, 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 click.
Chunka, 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 chunka.
The data playback rate was only 8 1/3 bits per second, which is, as Jack James, the project manager at one time said, it was a slow Morse code. And so it would take hours to get each individual picture back. So it was going to be days before you got all the data back.
8 days, in fact. This did not sit well when announced to the restless press assembled at JPL.
The performance of the spacecraft during the picture-taking sequence was not precisely as predicted. There were some anomalies, and we have attempted in this short period of time to diagnose these anomalies. We are still optimistic that we did indeed take some pictures. We have always said that we cannot determine whether or not these pictures have been taken, even when the system performed correctly, until tomorrow morning, when the picture playback sequence will be initiated.
And this was a time when life on Mars, and Mars was a very exciting thing. There were only 3 major networks in those good old days. They were all sitting in Von Karman Auditorium, getting very restless. They came to get their story, and they kept saying, well, the pictures, well, they're working on it. And so they began to get pretty nasty, demanding that this is the public's money, these are public data, which is true. Why can't we see them? Well, the answer was there wasn't much to see.
Difficulties in this business is that it's such a difficult game that your experience really tells you that almost anything abnormal usually spells disaster.
After what seemed an eternity, Mariner 4 began transmitting back images, assuming that was what was actually stored on the tape recorder. The pictures were to come back in the form of 1s and 0s, each number representing a shade of gray. The first numbers transmitted corresponded to black, as was expected.
So, they may be all black, but we got some there. Hey, there we go.
There she goes.
Yeah.
That's data.
Based on your preliminary analysis of this data, can you describe what you see on Mars?
Yes, it's there. That wasn't a fair.
Well,
Congratulations to you both, as a matter of fact.
Let's see what the picture looks like now.
Yeah.
Oh, boy.
Give me Bruce Murray's phone number. We're the devil or the Mars picture interpreters. Yeah. Data's coming in, boy. What are you doing in bed? You didn't, huh? Well, the numbers are coming in hot off the line. First, well, yeah, okay. Shave, at least.
The processing of images was far too slow for some. Desperate to see Mars, engineers took matters, or in this case numbers, into their own hands.
2 or 3 of us who had worked on the tape recorder came up with these schemes of how to try to sketch out the data in real time as it came in. And it was kind of a contest. And the one that won was essentially our adding machine paper tapes tacked to a wall. And that's the one that allowed us to kind of look at the data in real time.
And we created an image that way on paper faster than they could reconstruct the picture in a computer.
That first picture was from us engineers trying to figure out if the tape recorder was working because our bosses were saying, what do we tell the press? That's where the big pressure was. And at the point where some people noticed we were starting to put a picture together, they put a guy in charge of security to keep people away from the door. But people keep wandering in, so the word was spreading. Some people wanted to stop us from doing that because we would circumvent the PR release of pictures, if any. We said we're interested in the engineering and not the pictures, so they allowed us to continue. We then had enough fans collecting, and our immediate bosses said, keep going.
Kids are dancing. Is this the first time you've seen that? No kidding. Hey, that's gorgeous.
As you know, the more formal processing of these pictures is taking place.
Dr. Leighton from Caltech came in and looked at it. He really understood the data. He quickly picked up that the darkest of our numbers was actually the black of space. And he said, there's the limb, and he could start to look at the picture, and he looked like a happy camper, so. It's been a lot of fun because it was accidentally kind of the first picture of Mars.
So I thought I would close with, first of all, telling you some of the things that are going on here at the lab in terms of visualization. We have a lab here that is working on 3D with goggles that you can walk into their lab, put on these goggles. I've done this. You think you are on Mars because everything around you is in 3D. It is an extraordinary experience. And what is really exciting about it, not just the gee whiz factor, but the fact that our navigators, our drivers of our rovers, are going to be able to use this 3D dimension of Mars they see around them to help them drive the rovers. The scientists are going to be able, if they see a rock, a scientist, she will be able to go around the rock and decide, is that the rock I want to really explore, or is it that one over there? And this technology is just amazing. So that's happening here at the lab. But what you can go do that is also virtual, I highly recommend you check out Eyes on the Solar System. You can download this software off the internet, and it will allow you to go anywhere in the solar system you wish to go. You can go to Mars, and you can choose the spacecraft that you are interested in flying with or from its point of view. And you can go forward 50 years, you can go backwards 50 years. Just extraordinary experience, really fantastic for use in schools, I think, and working with students that are interested in learning more about the solar system. It takes you to any place in the solar system. In fact, it was very instrumental in trying to tell the story of the Pluto encounter. They used our visualization to show how Pluto was working. And a sneak just mention here, coming in just a few weeks is a brand new experience called Experience Curiosity. Look for that on the web when that comes out. Extraordinary. That will blow your socks off also. Very, very interesting. It will allow you to crawl all over the rover itself, get to understand the parts of it. You see a number over there. You can go over there. It's a place of science interest, and find out what Curiosity and the engineers and the scientists actually did at that spot. So I highly recommend that you go there. Okay. I want to end with my top 10 images, favorite images from Mars. This is Viking, landed in 1976, the bicentennial year. And that, to me, is just an extraordinary image. And look at how difficult it must have been, how lucky we were with all those rocks that we landed safely. And we did that with two missions, actually. I have this picture up on my office wall. And this is from Pathfinder in 94, I think. This was a technology demonstration. It was the purpose was to see if we could land on Mars using airbags. And some of the engineers here were interested in putting a rover on this technology demo of just could we land. And so the little rover there, not much bigger than a microwave oven, Sojourner, captured the hearts of people everywhere. And again, there's something about, something that is on Mars, moving around, that makes us feel that we are there. Spirit and Opportunity, the two rovers that we launched, I guess, 12 years or so ago. I love this picture because on the left, what you're seeing is a rover with a lot of dust on its solar panels. Mars is a very dusty place. And when that dust collects on the solar panels, guess what happens? The energy, the power that it has goes down. And we're really worried about losing the rover because the energy power source was getting so low. But lo and behold, nature took care of it and brought a dust devil that went right across the top of it and cleaned it off. Okay? What's very interesting to me also, and again, Mars Reconnaissance Orbiter took this picture. There's a dust devil seen from orbit. Isn't that beautiful? It's almost like art. The shadow in it. This is extraordinary. Mars Reconnaissance Orbiter 2. These engineers are really smart people. It is real rocket science. I mean, they calculated, knowing how this is the Phoenix mission that was a lander about, 7, 8 years ago, and they knew the path it was going to be coming into its landing zone, and so they trained first of all, they had to get the Mars Reconnaissance Orbiter into the right spot to take the shot, and they knew where to train the camera to take a shot to see the parachute as the Phoenix lander came in. And over the top of that crater is just incredible. Again, touching Mars, the wheels on Mars. They're a little banged up now because, it's not easy getting around Mars. Kind of tough there, but those are Curiosity's wheels. And it's just incredible to think about what we just saw a few minutes ago, 50 years ago, and where we are now. And that we can get down on the surface and feel like we're touching it. We're leaving a lot of tracks on Mars. Opportunity now has gone past the distance of a marathon. Has broken past that distance and is still roving. And the Curiosity rover, it won't go as far in terms of distance because it's going up a mountain, but it's going so far back into the past, telling us what is happening on Mars. And what's the 21st century without a selfie picture? Right? Incredible. I mean, that's on Mars. That's a picture taken from Mars. Isn't it amazing? This is my all-time favorite. This is the combination of the human imagination and technology. And this is technology too. These are the actual pastels that were used to make that picture. The engineers saved them and handed them over to us. We still have the pastels that made that picture. But I could do even better than that. Thank you so much for coming. You've been a great audience. I appreciate it so much.